Well, hi there, this is another project from me. Today I'm going to show you how to build a FM transmitter. FM transmitter, well, you can buy these, and I also recommend you to buy this if you want a good FM transmitter, and you can broadcast your own music to your radio. But what happened is that many people asked me, hey Stefan, can you please make a FM transmitter circuit? Can you show us how to build a FM transmitter? And well, although my personal opinion is that there are way too many videos on the web showing you on the web how to build a FM transmitter, I made one and I will upload it on the web. Okay, so here is the schematic and here is the final transmitter. That is how the transmitter is later going to look like if you are going to build it. I will show you step by step, video by video, how to build the transmitter, how to solder in the components, how to prepare the circuit board, and so far and so on. But before we start, I'm pretty much getting into some theory about transmitters. So here's the schematic, which also uses 2N3904 for all transistors. But let's start with the input. Here we have a 1K potentiometer where we can adjust the volume. So you can connect it to to an audio source that has like a line out level, which you can't adjust. But with this potentiometer, you can adjust it for good audio quality. A FM radio has a so-called DM phases in its receiver circuit. That means if you have higher frequencies, higher tones, it will lower the volume of these tones. And it will mean if you connect it directly without the so-called preamp phases, the audio quality ain't that good. So we have this circuit here with C1 and R1, which are in parallel, and they pretty much form a so-called preamp phases. What the preamp phases does is it filters out the higher frequencies and it amplifies the higher frequencies and then it gives them to the transmitter. But the problem is that the preamp phases is pretty much taking most of the volume of these signals. It's taking out the volume, and since of that we have to amplify it. This is a one-stage Class A amplifier which amplifies the weak audio signal to a better level. So this is simply like an audio amplifier. So here we have the main transmitter circuit, which is built around a bass circuit, also Colpitts oscillator. And this is a very cheap design that you will find many times on the web. It's just like a transmitter which is modulated on bass. And why does this work? Well, it uses a kind of waste effect of the transistor, because between base and emitter, as you can see in the schematic, there's a diode. And on these transistors, like the ones I'm using, this capacitance is quite big for a HF transistor. Anyway, and if you change the voltage on base to emitter, this diode will act as a variable capacitor diode, and it will also change its capacitance. That means if you change the voltage there and change the capacitance of this diode there, due to the fact that it's connected somehow to the tank circuit and also to the frequency defining components, it will shift the frequency. And that's what we want. We want to shift the frequency and we want FM frequency modulation. Another point is that of these circuits that you have amplitude modulation, since you're varying the current from base, and that will affect the output power of this transmitter. But it doesn't matter, since in the radio there's a circuit called the discriminator which changes the FM signal back to an AM signal. So it doesn't matter if there's some AM on our modulation, and the simple circuit is, for what it is, working quite well. Usually you find these circuits with an antenna connected to emitter, but I'm not doing that, since if you connect an antenna, the first thing is, if you're getting close to the antenna, the frequency will change. And the other thing is, these transmitters are producing harmonics. What does that mean? Well, very simple. For example, we tune our transmitter to like 100 MHz. And we add an antenna directly here on the emitter. Then we could receive our transmitter also on like 200 MHz, 300 MHz. That goes even up to 1000 MHz. Which is kind of cool, because you're using one transmitter and you're transmitting on like 10 frequencies. But no, that ain't that cool, because keep in mind, others are using these frequencies as well. So that's quite a problem. And what have I done? Well, the first problem, the antenna problem, if you got close to the antenna, the frequency shifts. Therefore, I've added this buffer amplifier, which also boosts the output power of this transmitter a little bit. And for the harmonic problem, I've added a so-called low-pass filter here. The low-pass filter allows only the FM radio band frequencies to pass to the antenna, but it will filter out higher frequencies like 200 MHz, 300 MHz. It will filter them out and allow only the FM frequencies to pass to the antenna, so you won't interfere with other stations. The transmitter overall power is quite low. It will cover your flat or home, and it will also cover like 90, maybe 120 feet in the garden. But I think that's alright, because the point of building these ain't really building them for using them in like a hi-fi application. You can buy these are stereo and these are absolutely frequency stable. No, you're rather building it because it's a good beginner's electronic project. It's very favored by people who build a homemade DIY FM transmitter. So don't expect too high ranges of this transmitter, but therefore it's also consuming not so much power. So you can run it from a battery, for example. Okay, here is the physical construction. These orange solder joints, or solder pads, not joints, these are pads, and these are these pads, for example, this pad or this pad. These are the solder pads, and you will see which parts go to where, and you can pretty much see that. So this is my physical construction plan. Here's about the coils. L1 is AWG 20 wire. It's wound on a AAA battery, and it has 3 turns. This is L1. And what is important about L1 is that the plates or the solder joints, the solder plates, are having a distance from here to here of 1 centimeter. So the coil is round about 1 centimeter long. And for L2, I'm also using AWG 20 wire. It has 5 turns, and it's made with these 2 solder connectors. They have a distance of 1.5 centimeter. And 1 inch is 2.45 centimeters. So you can pretty much calculate that by your own how much that is in inch. So here you can see the coil L2, and as you can see, I've also used some wire, but you should build it like this, because that's a really good working version. I've made many tests on this transmitter, and it's working quite well. So there's another physical construction stuff, how to cut out the circuit board, because you will need one of these circuit boards which has 10 by 10 centimeters. And then you're going to cut out stuff like that. You will see that in the further videos, and you will end up with some stuff like this. This is, for example, the front panel, where the LED and the RCA connector and stuff like that is mounted. And then you end up with a 5 mm by 8 cm thingy, which you will then cut into 16 times these small solder pads, which then will be glued on the circuit board. Anyway, what you need for this transmitter is a switch. Of course, you want to switch it on and off. Then a RCA connector, which is there for connecting the audio source. One LED, I use a yellow LED, you can also use a green or a red LED, it doesn't really matter. One DC connector for connecting the power supply, and one 3 feet or 90 centimeters AWG 20 wire. This one's needed for winding the coils, using it as 1 feet long antenna, and also, as you can see, some random other connections on the transmitter board. Okay, before I show you the transmitter transmitting, I have to say something about this video. I've made this diagram after I designed the transmitter, because I first started with this diagram. And you will see in the videos, you will see this circuit diagram, because it's the first version. But meanwhile I was developing this thing, I found out that there are quite some issues with the transmitter that I had to get over them. As you can also see, there are quite some values missing. That's because I've experimented them out meanwhile I was designing this transmitter. And yeah, that's pretty much what you are going to get, or going to get to see in the other videos. You won't see this schematic, which is the right schematic. You are going to rebuild it like this, because that's the final and working schematic. You will rather end up with this very basic schematic, which is my first drawing, which is pretty much unfinished. But you will see it in the video, but still follow old videos if you want to rebuild it, and you will have a good teaching how to build this transmitter. Anyway, the transmitter is already running. I'll take the radio, which is already tuned to the transmitter, turn it on. As you can see, it's transmitting. There's a little bit humming, but I'll explain that probably later. And now just push play. And you can hear it. If I turn off the transmitter, you can see it's disappearing, so that's really the transmitter transmitting my own music signal on the FM band, on the FM radio band. I'll turn the transmitter back on. Okay. That's pretty much the FM transmitter working. Best regards, Stefan.